Greetings, ladies and gentlemen. This is Professor Recore here, and today we're going to be working through some pH problems. So we come across a question on an exam, and it asks us, what is the hydroxide ion concentration in a solution that has a pH equal to 9? So in order to work through problems such as these, it's helpful to know a couple of equations. The first equation that we need to know is that the pH is equal to the negative log of the hydrogen ion concentration. The second equation that we need to know is that the product of the concentrations of the hydrogen ion times the hydroxide ion is equal to 10 to the negative 14th power. So knowing these two equations, we can begin to address our initial question, which was asking us, what is the hydroxide ion concentration in a solution that has a pH equal to 9? So the first thing that we're going to do is we want to find out, for a solution that has a pH equal to 9, what does that make the hydroxide ion equal to? That way we can plug it in to our second equation. Okay, so we're going to plug the pH in to our first equation. The pH is 9, so we're going to say 9 is equal to the negative log of the hydrogen ion concentration. Now, the log of 10 to the x power is equal to x. Okay, so in other words, the log of 10 to a certain power is equal to whatever that power is. So if we know that 9 is our answer, then we can make the assumption that the hydrogen ion concentration is 10 to the negative 9th power. The reason is because the log of 10 to the negative 9th power is negative 9. The negative log of 10 to the negative 9th power is positive 9. And indeed, positive 9 is the answer that we begin with. So we know our hydrogen ion concentration is equal to 10 to the negative 9th power. Now that we know this, we can use our second equation to find out the answer to our original question. So, knowing that the hydrogen ion concentration is equal to 10 to the negative 9th power, I'm going to plug that in to our second equation. That's our hydrogen ion concentration. We don't know our hydroxide ion concentration. And we know that the product of those two is equal to the value 10 to the negative 14th power. So in order to find our hydroxide ion concentration, I'm going to divide both sides of the equation by 10 to the negative 9th power. Okay, on the left side, that value cancels out. And then on the right side, we have 10 to the negative 14th power divided by 10 to the negative 9th power. Now, it helps if we know how to treat exponents that are being divided by one another. And in the case where we're dividing 10 to the negative 14th power by 10 to the negative 9th power, we're going to subtract the exponents. And now remember, when we subtract a negative, we add the positive. Let me show you what I mean. So we're going to subtract negative 14 from negative 9, right? So negative 14 minus -9. So when we subtract a negative, we add the positive. What I mean by that is that when we have this type of scenario, we add the positive. And so what is the outcome of this? -5. This is our exponent. So our answer of 10 to the -14th power divided by 10 to the -9th power is 10 to the -5th power. And indeed, 10 to the -5th power is our hydroxide ion concentration. Now, quickly, let's say our hydrogen ion concentration was equal to 10 to the -5th power. What would the pH of that solution be? If you're thinking that the pH would be 5, you're correct.